So we've got to deal with the sine of theta equals square root of 2 over 2, and we want to find all solutions. So a couple ways to do this. One way is we can just say, well, according to inverse functions, theta is going to be equal to the sine inverse of square root of 2 over 2. And there's one of those solutions right there, and I can just keep adding the period to this to get other ones. Right? So whatever that number is right there, plus any multiple of 2 pi. So usually we say 2 pi times k, where k is some whole number or an integer. So k could be 0, 1, 2, forever and ever, or -1, -2, forever and ever. So those are the integers right there. So if k equals 0, I get the first basic solution from the inverse function. Well, what does the inverse function tell us? Well, we should recognize square root of 2 over 2 as a special number. And so we should think about our first quadrant. And square root of 2 over 2 is where y is equal to x here. Remember, sine is the y value, and that angle right there is pi over 4. So the inverse function here is going to say pi over 4. So one set of solutions is pi over 4 plus any multiple of the period. So that would be 2 pi k. So k could be 0, which means that solution. K could be 1, which means go around once and then stop there. K could be 2, go around twice and stop there. If k was -1, that would mean go backwards till you get there. Now, think again, on the unit circle, sine is the y value on the unit circle. Y value is this one right here. So that also leads to this point over here, which the inverse function doesn't know about. But we know, due to the symmetry in our circle, that we have a reference angle of pi over 4. So the other angle to get from here to there would be 1, 2, 3 pi over 4. Would be the other angle. So my other set of solutions would be take 3 pi over 4 as the first one. And then if you add on the period or any multiple of the period, that's going to give you relatives of that solution right there. So I have two sets of solutions. I'm going to grab Desmos graph to colorize them. Let's turn that off and that off. Move that and screenshot you. So we go from here. All right, so then green solutions were related to pi over 4. That was this one right there. And then if I add one period, that gives me this one right here. If I add two periods, that gives me that one right there. If I subtract a period, then that would give me the solution I can't see, that's over here. The red answer, that would be my 3 pi over 4, which is right there. And then if I add one period, that puts me here. If I add another period, that's going to give me the next one out there. From here, if I subtracted a period, that would put me over here. So this one right here, as far as that description goes, this would be where k is equal to 0. This one right here would be k equals 1. This one over here would be k equals 2. This one over here would be k equals -1. And I can just keep looking to the left and the right to get more of them. So when we're talking about finding all solutions, we find the two base solutions and then just add multiples of the period. So that right there is just adding on multiples of the period for other solutions. And this is, pretty similar to the technique I used before if I wanted, say, the first 4 positive solutions. I found the first 2 solutions, and then if I add a period to that, I can get another one. If I add a period to that, I can get another one. And I just keep doing that all day long.